Hey, pre-calc, welcome to the Do Nows. We got two questions. First, list all the factors of 60. Yeah, straightforward enough. Secondly, some illustration and some background. I'll give you a bit of explanation before I set you loose on this. So, I grew up in Richland, Washington, where there are a lot of farms. It's all irrigated farmland, thanks to the dams and hydroelectric power, and we get irrigation as a result. And so, there's all these irrigated farms. They use typically this center pivot system. You can see in the picture over here what these things look like. Maybe you've seen them. So there's like in the center, there's like an axle where the water comes up into this big sprinkler thing, and then all those wheels are motorized. They're set at different speeds depending on how far out from the center you are, and so it rotates around. So the sprinklers move to this whole giant farm. So in the aerial photograph here, you can see right there in the center is where it would be attached, and then there's these different wheel marks for each of the different like wheels. Doot, 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 doot. And so the whole big long sprinkler system um, is represented by this radius, right? That green line there. Okay, so I did not grow up on a farm, but there's tons of these farms around, and so at a farmer near Richland, where I grew up, has a center pivot irrigation system. We're going to say the radius is one sprinkler length unit. All right, farmer walks 360 degrees all the way. He's gone all the way around the circle and comes back to where he starts, all the way around the circumference. And there's some questions for you to answer. So go ahead and hit pause so you got answers. I'll be waiting here for you when you're done. Hey, welcome back. So all the factors of 60, there's a bunch of them, 12 of them actually. I got them matched up, 1 and 60 is at the other end, 30 and 2 and so on. They're color coded, but you can see all of those factors. All right, let's take a look at this sprinkler. So I tried to color code the different parts so that they'd match what you see in the illustration. How many sprinkler length units does the farmer walk? Well, if the radius is 1, and we know the circumference is 2 times pi times the radius, it'd be 2 pi. Or if you prefer decimals, we can multiply 2 by pi and get 6.28. So 6.28 sprinkler length units. Is the circumference 360 times as big as the radius? Well, the circumference we just found was 6.28. The radius is 1, and that is not 360 times larger. So what is the numerical relationship of the 360 degrees to that 1 in the radius? I mean, it certainly doesn't tell you that the circumference is 360 times bigger. What is the relationship? Well, I have no idea. I don't know if you came up with something, but in all my years of math, there is no relationship between them. So, all right, we're going to learn about angle measure today, learning about radians. Maybe you've seen radians in a previous class, but my guess is probably most of you have not. So we're going to learn what is a radian. First, we get some history. Back to your 6th grade ancient history class, and we learned about the Sumerians from ancient Sumer. And the map, here we go. There's ancient Sumer. I try to just do one thing at a time here. So ancient Sumer is one of the oldest, is the oldest recorded civilization anywhere in the world. They did tons of important things, which are down here in the illustration. Here, we'll come back up to the words afterwards. So they built ziggurats. This is their temple, their big pyramids. They wrote in, they're the first people that left us written language. It's called the cuneiform. They wrote on clay tablets with the like you press a stylus in and make these little wedge-shaped things. Those are different letters and words, and can't read it. I don't know what that is. Among their writing, they gave us the oldest recorded epic poem. It's called Gilgamesh. At one point, it was made into a movie, which was not the greatest. I never saw it, but I heard it was not the greatest movie. Anyway, relative to us, they did some work in math, and so they left a bunch of written documentation about their math work. They used a sexagesimal number system, which is base 60, right? So our number system is base 10, so we've got 10 numbers into divisions of 10. You know, if you counted by tens, 10, 20, 30, 40, and so on. Okay, so they would count by 60s, 60, 120, 180, 240, 300, 360. Okay, it was super useful for them because most of their math centered on calculating taxes on rectangular farms. And since 60 has so many factors, that made it really, really useful for them. So you'd have all these different rectangular sizes that would you just calculate the area very easily, and they'd be able to derive the tax system from that, right? So our current usage of many numbers actually comes from ancient Sumer. It's like the oldest civilization in the world. We just haven't changed a lot of stuff since then for, I don't know, because that's the way the people before us always did it. So 60 seconds in a minute, that's because sex adjustable number system is base 60, 60 minutes in an hour, same story. 360 degrees in a circle. They said, well, we'll just count up a couple of divisions, 60, 120, 180, blah, blah, blah. We get you 360. All right, there's a circle. Same for the calendar. Their calendar had 360 days that counted. And then they knew that didn't quite work out. So they added 5 feast days or 5 holidays that didn't actually count towards the calendar. So it's 360 days makes a year, plus there's 5 extra days that don't count. Okay, so there's all these relics of the most ancient civilization in the world that are just like all over the place and we don't even know it. And like, why are they still there? Okay, well, some of them, it doesn't make any difference. 60 seconds in a minute, whatever. That doesn't make any difference to us one way or the other. But in mathematics, some of these things do really make a difference. Like 360 degrees making up one complete circle. I mean, that's cool if you live in ancient Sumer, but as mathematics got more complex, degrees became increasingly cumbersome. It's just like, I mean, we can use them. Obviously, we've learned a bunch of stuff using degrees, but it's just really not the most useful system. And so mathematicians said, you know what? There's really no reason to keep 360 degrees as our measurement. Let's invent a measure that makes more sense for the purpose of mathematics. Okay, so that's where we get a radian from. Mathematicians invented a radian. It's based on the size of the radius of the circle. It describes an angle using the intersected arc length measured in terms of the radius. Okay, so in my illustration here, there's an arc in red. There's the arc length. So around the circumference, you cut a piece of that circumference. That is called an arc. You learned about this in geometry class. The length of that we're going to describe in terms of whatever the radius is. So if you take your measuring tape, you measure out the radius, you say, all right, this is the radius, we're going to call that 1. Here's my length. Wrap that around the circumference and 1 radius. When it is wrapped around the edge of the circumference, that's called a radian. So a radius and a radian, they are different words. They refer to the same measurement, right? And then the reason mathematicians chose this particular size is because a complete circle is going to be 2 pi radians. That's how we calculate circumference, 2 times pi. And so that is where they got a radian from. Okay, so let me show you an illustration of what a radius, how a radius translates into a radian. So I get a circle. We can see here is the radius drawn in blue. If we start wrapping that around the circumference, you can imagine like a little eye hook at point A, and we're gonna like pull yarn through that little eye hook and then wrap it around the edge of like a spool, right? That's what the circle is gonna be. So we change the radius of the circle, it won't actually make any, I mean, we'll look at that, but so you can see we're pulling the yarn, pulling the yarn, pulling the yarn. Oh, if we get that far, the blue section there is 1 radian. And then we're getting another strand of yarn that is the size of the radius. So just tie that on there. This one is red, so we can see the difference. And then we'll pull that through our little eye hole and wrap it around the edge of our spool. And then we get another one once we use up the red one. And then here's a blue one, right? So you get the blue section, that's 1 radius, 1 radian, now that it's wrapped around. The red section, that is 1 radian. The green section currently is a radius, but once we pull it out and wrap it around, it will become a radian. So as we go around and around and around and around and around, we need how many of these radians do we need? We're going to need 6.28. Right, so here's 6 complete ones, and then this pink one will be our next one. We're not going to use the whole thing once we get all the way around 1 complete rotation. We've not used the whole pink strand. We only used just over a quarter of it, 6.28. That's 2 multiplied by pi.